welcome back to the second session of our AI workshop or seminars. So in fact, in first session, we try to look at different area of AI, the basic concept around the AI, such as a definition of AI, machine learning, deep learning, how machine can learn from the data, and then we dive a little bit into the concept of natural language processing, computer vision, and in the second session today, I'm trying to give you an idea about the roadmap for implementing AI applications or systems and what is the life cycle for this. So in fact, at the beginning, we will check the life cycle of AI project from the beginning to the development, and then we try to understand the role of AI and the impact of availability of the data and how data can impact on the AI system. What is a data strategy and how should a data strategy should be considered in a different organization or setting to be successful. And then we will look at the feature engineering, modeling, and the different methodology to somehow manage AI project. And at the end, as some hint, we will try to look at the budgeting for AI project. I think some of the concept will be very basic, but we have some concept that need more deep understanding specifically when it comes to developing. Is there anyone who has familiarity with the developing AI system? I just want to get an idea from the audience. Have you been involved in the developing of brilliant? What kind of?
We'll start with coding stuff. I wouldn't say I'm doing it. I wouldn't say I'm an expert in it, but we're in that realm of building stuff and building apps around.
Great. Okay, so I think definitely there is a lot of things that you can benefit from it. So at the beginning, let's see how we can develop an AI system and what is the steps for development. So any software project, any technology project or engineering project needs to have to follow some sort of life cycle to achieve the goal of the project. So, and we have the same concept. Yeah, please. Very welcome. Please find a place for yourself. Yeah, so the AI life cycle, it shows us how or what kind of step do we need to consider during developing an AI. So, as any engineering project, at the beginning we need to find a pain point in our business. So, finding the problem inside the business is the starting point. By finding the problems, creating a problem statement, and defining the requirement around that, so we try to shape and scope a project. So the scoping or business understanding or problem understanding is the first step. Is the same for any other engineering principles. Then when we have a solid definition of our problem, we can go into the next step. So as you can see, I use different colors for different steps. Because we can somehow put them together in different phases. For example, the first phase is business understanding. The second phase, as you can see with the green color, is all around the data. So when we have the definition, when we understand what is the problem, we need to collect data, find the sources that can use for generating the data sources required for the AI project or the AI problem related to that problem. So in fact, we need to find the best or most relevant data. Then we need to ingest them or integrate them. For example, let's say if you want to create an AI system to target our customer, so you might have a CRM system, customer relationship management system. All the client or the customer information sit inside the CRM. At the same time, you have, for example, a financial information or data about your client. So how we can use those, for example, these just two sample data set to create a system. At the beginning, we need to integrate them together. In fact, we need to extract the data from different sources, bringing to a same environment, and then we will run the pre-processing or data cleaning. So the pre-processing, when you want to, in fact, preparing the data for training purpose. So if you remember last time, we mentioned machine will be trained using the data. We will pass the data, machine try to extract the patterns and learn from those data. So the data preparation is the step that can help us to change the data to a format which is suitable for training. And then we have the data visualization and analysis. When we try to create some visualization to understand different aspects of our data. For example, the distribution of the data. Let's say if you want to find out the age distribution among our customer. So if we try to create a, for example, diagram and check the diagram, get the insight about this distribution is much easier. And then when we have the data ready, we will go to the next step, which we call it modeling and evaluation. So during the modeling, we have a feature engineering. I will dive into the detail in the next slides. I'm just trying to give you a highlight or overview of the whole process. We have the feature engineering when we try to create new features, select most relevant features for training, and somehow extract the best data for training purpose. Then we will train a model and evaluate the model to check the performance of this model, because this model at the end of the day should do some sort of prediction, or maybe it needs to produce some sort of output. And this output, at the end, they need to meet our business goals. Because from the beginning, this system developed to meet some of our goals. So, if the developed model meet the business goal, we will deploy the model into the production. For example, we might integrate the AI model inside the software, and then user can access the software and interact with this AI model and get the prediction or result from that. For example, ChatGPT. I believe lots of people know this obvious sample for AI model. So in fact, it trained on the data, it evaluated against some metrics, and when they satisfied with the output of this model, they put the model inside the software environment, which has, for example, a web interface, and now we can interact with this interface to get some, for example, result, predictions, text output, or maybe code generation, or image description, and different kind of task. So based on that, during the production, when the user try to use the AI system, one of the important part is monitoring, because AI, compared to the software and other engineering, it has some sort of dynamic behavior. We cannot expect AI model to predict or act similar in different situations. They are probabilistic. In fact, they are based on the probability, and the probability of the output can impact on the generated data by the AI model. So this is a whole perspective, or the whole life cycle. And as you can see, there is a loop or feedback or some sort of arrow that it will try to return to the previous step and start from the beginning. For example, if the model that we trained is not meet the business goal, we will go back. Sometimes we need to gather more data. Sometimes we need to improve the modeling process or architecture of the model, and somehow it will impact the whole process. Let's look at each step now separately, because it's a little bit heavy, I think. Yeah, or not? So the first part of the process is data collection and understanding. When we have a problem, to solve the problem, we need to find the relevant data, identify the source of those data, then think about that, how we can use data to solve the problem. So the first step is data collection and understanding. And what means, when we say data understanding, it means we need to have a good understanding regarding the data features. For example, textual data could be completely different compared to the visual data, or data that we store in a databases. They have a different characteristic compared to unstructured data that's stored in the files, or let's say visual elements. So because of that, having a good understanding regarding the data can impact in our process and the system that we try to create. And as a data, we have three types of data. Can you see, I'm just asking this question definitely for the future session. I think the font is a little bit small, so everybody can see the screen, or, okay, great. Just to be sure, maybe for the future session. So, when we are talking about the data, we have structured data, those data that's stored inside the database, the tables. There is some sort of, for example, rows and columns, and each row related to different entities, and it tries to store information about specific entity. We have unstructured data, as I mentioned, similar to the text, speech, video, image, so they don't have any structure because we cannot find any structure. We cannot put them inside the row and columns. And then we have the semi-structured data, specifically the people who they have a software background. For example, we have the JSON files, we have the XML, we have Excel files. They are not fully structured. At the same time, somehow there is some sort of information inside the data that we can use that structure for our purpose. Okay, now we identify the different data sources. We need to ingest this data and integrate them together. As I mentioned, for example, we have data from different departments in one organization, and we find out, for example, data from 3 departments should be integrated together to create a system. So data integration is one of these processes. And we have different techniques for data integration. Extract, transform, load, ETL, or extract, load, transform. or using the API-driven approaches. Specifically in today's, I think this is a new approach to somehow put everything together. So let's visualize everything. It make the process, I think, understandable. For example, in one organization, we might have a database of, for example, pay slips, payment to the staff. We have some sort of files, let's say, CV of the staff. Then we have a SaaS application, an application that we use inside our organization. Let's say, for example, Jira, a board for management. So every day we try to, for example, allocate different tasks to our team members. Then we have application events. There is some sort of event can happen inside a software. All of those, some sort of data sources. Then we can extract these. In fact, we need to develop code or create a system that can extract all the information from different sources, then pass them to a staging area. Staging area is a place that we try to load everything right there and then run a transformation. So the transformation is changing the data. In fact, it will convert the data from one shape to the another. And specifically is important for data analytics, business, intelligent purposes. For example, when we want to have the data in a format that is ready to use. Then we will load this information when we transform the data. We will load the data inside the places look like a data warehouse. Data warehouse is a place that all the data from different locations transformed and prepared and stored in a structured way. And then we can build an AI system on top of these data warehouse. Is there any questions? I just want to get a feedback from you. Is it, do you have any background about this process or?
It reminds data analysis process.
Oh, great.
Collecting in and out data, storing, structuring.
Yeah, exactly.
Is there any preference on what type of data warehouse? I'm assuming it's some sort of vectorized system when you're going Redis or.
So this is I think one of the hot topic at the moment. You can store data anywhere. Depend of the, I think, technology stack in the different organization. You can consider all the options. Let's say, for example, if the technology stack inside the organization is Azure, so you can think about the, for example, data fabric, and you can think about the data lake as a, for example, a place to store all the data. But if you, let's say, for example, if you have lots of documents that you want to, specifically today with the new application of RAGs or retrieval augmented generation. So in fact, vector databases is one of the best options because you can run the similarity on the content of unstructured data. You can convert the, for example, let's say text, image, video, any kind of data to the vector or numbers and run the similarity search on those kind of information and retrieve the most similar information based on the user queries.
Wouldn't everything be text technically? Because regardless of what system you're taking it out of, you're storing text and ultimately in the data warehouse, you're storing vectors. They're not embedded vectors.
For the vector database, it will be number because at the end of the day, it's all numbers. But for data warehouse, it could be anything. Or for data lake, for example. Data warehouse it has more structure. In fact, is look like some sort of database that that has some different rules. But with the data lake, there is no rules, and in fact, you can load everything directly into the data lake. Yeah, and when we have those, when we extracted the data, as we mentioned, we have the data preparation and cleaning. Always, this is one of the very time-consuming and specifically costly process in the AI project development. When you have the data, you need to go through the data, find lots of problems. Data is not tidy, is not ready to feed into the AI model to train them. For example, let's say, you will find out lots of missing value. During, for example, it's a nature of human. During data entry, we might forget to, for example, enter the data for some of the options that they ask. Or maybe they are optional. They are not necessary, so not required. And because of that, we skip the data entry. Or maybe the data is not in the format which is suitable for training the AI model. So because of that, the data preparation and cleaning is another step that we need to consider. And when we clean the data, we can run the exploratory data analysis. And we call it EDA. EDA is a process that tries to visualize the feature of the data. So if you have a data set, how we can understand the statistical aspect of this data. Let's look at the example. I think it will be easier for us. So in this data set, we have a car data set. Just let me to, I think I need to bring that one to the other. Just bear with me. It should be here, yeah. At the beginning, let's look at the data set. Kaggle is a website that you can find lots of data sets or open source data sets. So in fact, if you want to, for example, find some sort of data to play with the data and maybe create a samples, AI samples model, so you can use the Kaggle. This one is very simple one, car feature and MSRP. So in fact, this is a data set that contains some information about different cars, and we will try to use this data set to predict the price of a car. Okay, let's go back to the code. As I mentioned, I put very simple code just to give you an idea. What is the exploratory data analysis and what is the process of data cleaning? So I will skip the description that I put there. At the beginning, we will read the data. So this is the first 5 rows of our data set. It contains the make, the model, the year, engine fuel type, engine horsepower, engine cylinders, transmission type, and so on. So we have all those information, and the last column is represent the price of the car. Okay, we can check this is the first 5 row. We can check the last 5 row as well, so just to have an idea. In fact, at the moment, we have around 11,913 rows inside our data set. So we can say it's a small data set. From AI perspective, is not a big data set because 11,000 is very small size. Okay, what we can do, the first things that we can do is understanding the data. And in our area, we try to check the type of those columns, for example, those information. Then we can drop some of the irrelevant information that doesn't impact on the price of a car. So in this case, I said, for example, some of those column or information doesn't have any impact on the prediction of a car price. So for example, engine fuel type, market category, vehicle style, popularity, and so on. So we drop a list of those columns because they don't have any impact on the prediction. Then we can check the rest of the column and somehow rename those columns just for our understanding. So in fact now we have a very small data set, be it those columns: make, model, year, horsepower, cylinders, transmission, drive mode, MPG in highway, and MPG inside the city, and the price of the car. One of the main problems always in the data set, duplicate information. For example, you might have a simple data set. We might have a similar information for one car. Or if you have a customer, maybe the customer tried to register multiple times, and you don't want to have duplicate information during the training because it not bring any value to the training process. So removing those duplicate is important. And also, we drop. At the beginning we had 11,914. After dropping, we have 10,924. So in fact, we find some duplicate. Then we can drop missing value. For example, in this case, we can see there is a 30 car that we don't have any information about their cylinders, number of cylinders, and so on. So I will go, this is the process or the pre-processing step of AI lifecycle. And then we can check the outliers, because outliers is really important during the creating any machine learning or AI system. For example, in this case, we can see there is some, I think 4 outliers, 4 cars, which the price of the car is more than 1 million. And if you want to try to include these information inside training process, definitely it will impact the prediction of our model. So we need to remove them. Or there is a cars, for example, for horsepower, the power of the car. For example, we have a car with 1,000 horsepower, which is not too much realistic. So we need to drop that one. And so on, or the number of cylinders. When we clean the data, now we can check or run the exploratory data analysis to see some sort of basic insight about our data. For example, in this case, I said to look at the number of the cars per make. So for example, in our data set, Charlotte has almost around 1,000 cars. But we have very little data about the other brands like Genesis or, for example, Maserati. So in fact, if in the future, if we try to train a model using this data, and if you want to try to predict the price for example, a car in that site like a Genesis or Maserati, the output will not be realistic. Why? Because the training data doesn't have enough samples from this population. And then we can, for example, plot the heat map. Is some sort of exploratory. So because we want to predict the price, with the heat map, it's so easy to find the most relevant feature that can impact and help us to predict the price. In this case, so the higher relevant is the dark blue color, and the less relevant is almost orange dark, somehow look like that. So if you look at the price column, it shows the year and the horsepower and number of cylinders have a positive relationship with the price of the car. So in fact, if we have the year and the horsepower and cylinders, we can predict the car price easily. And from the other side, MPG in highway and city has a negative relation with the car price. So this is a just very simple visualization that can help us to understand the features of our data. Or somehow we can check the relation between each feature with the price. For example, in this case, horsepower with the price. The cars who they have a higher horsepower or they are more powerful, the price is higher. It's easy to find those. But this process, as I mentioned, is important. Sometimes just with this process, you can extract very, very important information that cannot be obvious but looking at the numbers. In one case, let me to give you another example from my experience. So I work on a project for healthcare sector, in fact. They try to find out the main pain point and bottleneck in the process of visiting people. When the people try to visit GPs, they find out what is the main bottleneck in the process of, for example, visiting clinics and healthcare process. So what I did, I visualized the route that each patient went through. So we gather patient information, their appointment time, what kind of appointment do they have, and how long the appointment it takes to, for example, be in place. And after that, we find out, if we just tweak very simple process, it can impact a lot on the performance of the clinics. For example, we find out if we move the short appointment to the beginning of the day and longer appointment to the end of the day, it completely changed the performance of the staff of the clinic and also the number of patients seen by the GPs. So with visualization, you can find lots of useful insight. This is the first step or some sort of, I think, part of the process to understand our data. Let's go back to the presentation. Is there any question, concern? So you are not tired? Okay, great. Data strategy. When we are talking about the data and AI system, having a strategy is very, very important. So, in fact, data strategy is a plan that outlines and shows the organizations, how organizations collect, store, manage, and keep the data secure. So in fact, it is a plan. Without any data strategy, an organization cannot survive, specifically in these days. So it's important to know how we can gather the data, where to store the data, how we can keep them secure, for how long we need to store those information. All of those concerns should be integrated in a data strategy, and data strategy has a different component. So let's look at those components. The first one is data collection and acquisition. We need to understand how we can collect data. So I think we are very familiar with the process of data collection. Lots of specifically big brands at the moment, they try to use and offer free of charge products. Let's say every day we are using WhatsApp, Gmail, all of those products is just for one purpose: data collection, nothing else. So in fact, this is a very important point. The companies like Google, Facebook, Meta, Amazon, all of them, they rely on the free data. They provide a service. They help us to use a free service, but in return, they use our data, the data that's generated by ourselves. Okay, now we have the data. We find out in our organization how to collect the data. Maybe we don't need to develop a free product, but we can identify the source of those data. Then we need to find a place to store those data. Are they going to sit inside, for example, data set, or are they stored in Excel sheets, or, for example, as a file on our hard drive? So we need to find that, and we need to manage this process. Then we need to integrate them and provide accessibility. So for example, if you have an organization with, let's say, for example, 5 different departments, how people from one department can access the data of the other department? Is there any specific rules, regulation, or policy to allow them to access or not? So this should be defined inside the data strategy. And then when we define those, we have data governance. Data governance is about the management, how we manage the data, how we try to share the data, how we can store the information about the main data. And data lineage is try to show the root of the data, because as we mentioned, we have a pre-processing or cleaning process. So how we can find these data, the original location or source of the data at the end. For example, if we have a transformed version of the data, we need to know the source of the data, the original place of this data. And finally, all those processes at the end need to generate a value for the business, because we are not spending money, we are not investing in anything without any value. So the last part of this process is value generation, where we can, for example, extract insight, where we can get some useful knowledge out of this information, or where we can, for example, develop an AI system that can save cost, reduce our operational cost, or maybe improve the processes inside our organization. So this is just sample. Just let me to find my mouse and use the laser point. This is just some sample example for creating a data strategy for an enterprise or an organization. And we call this data strategy as a fair. So in fact, data strategy should be findable. It should be help the people to find the data. It should be accessible. The data should be accessible. It should be interoperable, also reusable. So in fact, this is 3 different characteristics that we need to consider during creating a data strategy. And from the other perspective, data strategy should be aligned with the business goals and objective. So if you have a data strategy, it should be exactly on the same page with the business objective. For example, we cannot decide to use for example, papers to do our daily work in our organization, and then we cannot say we have a data strategy to manage those data, because they are in a different direction. Having papers and having a data strategy far from each other. So there is a different layer, in fact, for data strategy that should be considered. In the lower layer, we have all the data sources, from the databases, big data, or unstructured data or semi-structured and any kind of document that you have. Then on top of that, we need to create a data asset planning, so a plan to store all the data. We need to have a plan about the security, how to integrate those data together, and what kind of metadata we need to consider. And then on top of that, we have the data, using the data for strategic advantages. So we need to have a master data management plan to understand how we try to manage our data assets. Maybe we have some sort of data warehousing when we try to gather and put all the data together. We might have a team of data analytics who they want to extract insight from those data, or a team of business intelligence that they can understand our position and help us with the understanding our business better compared to the competitor, data quality management or data architecture and modeling, those different aspects of the business. But at the end, we have some people inside our organization with the processes, policies, and culture, and this is the main governance concept or element of a data governance. And on top of that, we need to have a data strategy that is aligned with the business strategy, otherwise we will fail to use the data in the right direction or to generate a value for our business. Okay, I think the data strategy was so boring from your face, I can see. Is there any question, any feedback, any concerns? Have you had any chance to, for example, interact with the data team in your career, or maybe somehow?
I think the big problem is getting access to data, so across the organisation.
Exactly.
Governance models, getting that through data protection teams. And also, when you do that ETL task, you can sometimes lose some of the auditing features of it because the models, the repository that you're going into tends to be quite naked data in a way. And then people say, well, how do we know what happened or what that model looked at? Or when this person ran this query about that model, were they allowed to look at that data?
Yeah.
And I think that the whole data governance structure and mobilizing that data in an effective way is probably one of the biggest challenges.
Exactly, and because of that, I think having a data strategy is impact the whole organization process, specifically for the people who they try to work with the data, or their daily work is based on the data. So I think it depends. Sometimes it depends the size of the organization. Specifically in the startup, I think setting is more agile and easy to, for example, go around the policies and define the, I think, processes to access or share data. But with the, I think, large organization, is so difficult to pass different, I think, policies in place, and having team that they have a different or conflict objective or interest, sometimes it could be difficult to access the data. Yeah.
I think we found we have to deal with a lot of SOX compliance and things like that, and anything with figures, they get very sensitive about it. What are you doing with this? Why do you need access to this finance data? So, for example, if we wanted to do that car model that you just did there, if you wanted pricing data on cars, for example, and you had your own internal source, they get very sensitive about it.
Yeah.
We don't want to tell you how much we sold a car, for example, because that is, and they'll just say, right, go to cap or something like that, or glasses data in the car example.
Yeah. Yeah, so because of that, I mentioned alignment between the business objective with the data strategy is important. Because if in the higher level of the organization, if they don't have a good understanding of the value that data can generate, so definitely they try to be a barrier and put more, I think, processes to somehow prevent the access. But if there is a willingness in the higher management, it gets more easier, specifically with that one. Brilliant. So next section is about the feature engineering and modeling. Now we have the data. Okay, how we can give this data to the AI model to learn from them and predict for us or maybe generate something for us. So we call this process feature engineering. In fact, feature engineering is the process when we try to use the domain knowledge to transfer and tweak the data to a format that is suitable for training. So in fact, we want to prepare our data, and it can be in a different style. So for example, during the feature engineering, we try to generate new features. Let me give you an example. For example, in your data set, you might have date. So date, we say, for example, 21st of March, 2023, okay? But how we can extract more information from this piece? So how we can get extra data? So in fact, we can extract the year, extract the month, extract the day, and then we can maybe extract week of a year or which day of the week. So this is just new information from one small piece of data. So this is the feature creation. We try to create new features. Or feature transformation, changing the data from one shape to the another shape. Specifically, when we try to scale the data in a similar range. For example, let us say if you want to predict the salary of a person based on the age, on the, let us say, for example, locations, so if you have a different data, sometimes we need to scale them to arrange them or set them in a similar range. And feature transformation is one of those. Or feature embedding, when we try to completely change the data. For example, for text data, if you remember last session, we mentioned we cannot through the text to a AI model to learn. We need to convert the text to the numbers, which we call embedding, and then pass the embedding to the model to learn from them. Or feature selection. Always all the data, they are not have the same impact on the output. Selecting the most important items and just passing them is another step. So for example, if you want to train in this case, we have a very lovely duck, a photo of a duck. And we want to train a model to tell us is this photo is a dog or not. So this photo is 64 pixel by 64 pixel. And we cannot pass the photo directly to the model. In fact, we need to convert the photo to numbers. How we convert the photo to number? In fact, we have 3 channels, red, green, blue, and each pixel in this photo has a value between 0 and 255. So, and we use those numbers for training the model. In fact, we put all those numbers together in one line. So this is the feature engineering process. And then the output will be 1 because this is a photo of a dog. So this is some sort of feature engineering. Okay, now we have the data which is ready for training. Now we need to select, the next step is the modeling. We need to select from different algorithms. Based on the task in hand, we can select the appropriate algorithm for training. Hello.
Loghman knows in the
Oh, no. Oh, great. No problem. Okay, so the model selection, in fact, we try to find the best algorithm for training for the task that we want to solve. When we have the model or the algorithm, we will train this algorithm. How we can train? So in this case, for example, if you have 1,000 of photos, we will convert all of them during the feature engineering to numbers, look like that. And we have a neural network. So we will pass first photo to the neural network, and it will pass and calculate some number and pass the number to the next layers. And finally, it will try to predict an output. So the output will be 0 or 1. 0 is not dog, for example, in our case. 1, it will say this is a photo of a dog. And then we can compare the prediction with the real value. In fact, at the beginning, we know we labeled all those photos. We know, for example, the first photo is a dog. The second photo is not a dog, and so on. And then we compare the prediction of the model with these real labels. And based on that, we try to fix the model, try to help the model learn. So this is the process of model training and learning. And then when we train the model, it's a time to evaluate the model. So during the evaluation, we will collect another data set, so completely separate from the training data set, and we pass this data set to the model, and we will check is the output of the model is really correct or not. And based on that, we can check the performance of our model. And when we satisfy, then we can use this model in the operational environment. Let to show you an example of neural network and how they train, how they learn from the data. So in fact, if we try to open that one, I think we have the not here, it should be here, yeah. Great. So this is look like a playground that you can create a neural network. If you don't have any knowledge of, for example, coding or anything else, it will help you to understand how a neural network works. So in this case, in the left side, you have some data. For example, you can select this or that. So the distribution of the data is different. For example, if you select that one, we have two classes or two groups of data, the blue one or the orange one. In this case, is look like a circles, the blue one in the middle, but sometimes maybe data distributed look like that. Or maybe we have some sort of data that the distribution is completely different. So what we can do, we say we have two values as an input, x1 and x2. This is the input to the model. And then we have two layers in our neural network. The first layer has 5 neurons, and the second layer has 2 neurons. And finally, there is a output layer which is generate the final output for us. If you like, you can, for example, increase the number of layers. Let to add another layer. Also, you can add more neurons to this layer, if you like. And then you can set some hyperparameters or parameters that impact on the training of this neural network. Here, for example, the learning rate or activation, I will not dive to those concepts, so it's just general. And then you can start training. So if you look at that, it is try to learn from the data. In fact, we pass the data from left side, and after a while, it is try to find a boundary between green and orange data. And is still struggling to find the best boundary between them. And the reason is the shape of the data and also those hyperparameters that we have. By the way, this is the process of training. I just want to visualize the process for you. So I think after 2,877 times of feeding the whole data, it couldn't prepare or generate an acceptable output. But for example, if you try to change the data to this one, it might be much easier. As you can see, very easy, it could find the boundaries between the two groups, the blue compared to the orange, and it needs less than I think 10 iteration of the data of training. Is there any questions? Any feedback? Great. Is it? Do you have familiarity with those concepts or? Brilliant. Great, so let's go back to the presentation. Now that we trained, let's see some other example. In this example, predicting customer churn using neural network. So we want to predict, is a customer try to leave our services or not? So I think it's better to go back here and look at the example. For this example, again, I use a data set from the Kaggle. So the data set is for a telecom company. In fact, they share the data and provide the access to the data. It includes this information: customer ID, gender, senior citizen, partner, dependents, tenure, phone services. So in fact, they try to put all the data about one customer in one row. For example, this is one customer and the information that we have. So for example, she is not using the phone service. She doesn't have, in fact, multiple lines or internet service. She used the DSL service and so on. So in fact, if you go to the end, we have the churn as an output. So this customer doesn't churn. So in fact, she didn't leave the telecommunication, this company service, so she's still using the services of this company. Okay, now before we want to prevent this process, we want to predict if a customer try to leave or not. And if the model predicts somebody try to leave, we will try to reach out with some good offer to them and keep them in our customer base. So it's easy. Again, we have the process of cleaning and pre-processing of the data. I will skip them. So in fact, we cleaned the data, we changed the style of the data, and we converted all the data to the numbers. So this is the process of feature engineering and pre-processing of the data. Then we divided the data to test data set and training data set. In this case, I said let's keep the first 10 customer for testing. So we will keep the information of those customers, the first 10 customers for testing the model at the end. When we train the model, we will pass this information to the model to see how it can predict the churn of the customer. Okay, we divided the data set to train and test, and then we created a neural network here. This is the structure of the neural network. In fact, as an input, we have 6,570 neurons in the first layer of the neural network. It's different compared to the other visualization, just to give you an idea what we have. Then, in the second layer of our network, we have 32 neurons, 68, and finally 1. So the last layer has just 1 neuron, and it will tell us this customer is churn or not. And then we train the model. So we pass the data multiple times, we train the model, and then now we can run the prediction using the model. And this is the output of the test data. So, for example, for the customer, for the first customer, the trained model said it will churn. The value is 1. But I think in the real world, so is 0, is not churn. So it shows the model doesn't perform very well, for example. But we can look at the rest as well. We have different metrics like accuracy, like F-scores. I will not dive on those concepts. So in fact, we have different metrics. We can check those metrics, and based on our requirement, we can decide, is this model trained and perform well enough to put in the production and use in our daily process or not. So this is one of the examples. The second example that we have is a little bit different, working with the visual data. We have a data set for handwritten digit. We call them MNIST. So MNIST is a data set of, I think, we have 60,000 images for training and 10,000 images for testing. And it's very simple. So we have a handwritten digit as an image, and then what we want to do, we want to create a model to tell us is the digit is greater than 5 or less than 5. Very simple model. So again, we need to go through the process of getting the data, pre-processing the data, and running the feature engineering. In this case, also we need to change the label, because the label, if the number is 5 or less than 5, output should be 0. If the number is 5 or greater than 5, it should be 0. Otherwise, if it's less than 5, it should be 1. And then we created the neural network. The same process is going on, and then we train the model, and finally we can visualize the process of learning. So for example, in this case, loss is a metric that we can check how much these neural network learn well, or how much had difficulty to learn the data. So the blue one for the training data, and the orange one for the validation data or testing data. And as you can see, by going forward, the training data, the error rate for the training data is coming down. It's similar for the testing data, but it could be better. Also, we have for example, accuracy, as I mentioned, is another metric that you can use to somehow see the performance of your model. Those just some samples to give you an idea about the process of feature engineering and model training in the AI system. Is there any questions? I don't want to be speak alone. Give me some feedback. Yeah.
So it seems to me that the most important steps in the accuracy of AI prediction would be data accuracy and the accuracy of the data model. So I have two questions. So when you do your data cleanup validation, do you always use your error decorrelation based on sort of set of parameters? Like, for example, you eliminate the outliers instead and the oddballs. Do you always go for the largest statistical average, or do you use, like, let's say, bespoke approach for every business problem?
So it depends on the problem. The question is about how we try. I'm just trying to repeat the question for our online attendees. So the question is about how we try to go through the feature engineering and how much data quality can impact, in fact, on the model, and the accuracy of the training data, in fact, impact on the accuracy of our model. And
not even about error decorrelation.
yeah, and
How do you do that?
and if we, for example, if we try to remove the irrelevant data from the training. So the answer for this question, I think, as I mentioned, is depend of the task in your hand and the type of algorithm that you want to use. So in traditional machine learning, it's very important to have a clean data and tidy up everything. With the modern or deep learning model, we don't need to do lots of data cleaning and preparation. For example, let's say now having a model look like a ChatGPT, Llama 2, or any of those large language model. So they learned from the text that it's somehow scraped from the internet, from the web. And they didn't run any pre-processing on the data. They just scraped the data, gathered the information, text from the internet, and passed the data to the model. And the model, because the size of the data is really huge, so it will not, it doesn't need some sort of pre-processing, feature engineering, and those kind of function. But as I mentioned, sometimes based on the task, you need to go and you need to be really careful about the quality of the data. For example, for predictive model, such as a car price prediction or house price prediction. So in those cases, we need to clean our data. We need to find the most relevant feature and use those features to train the model. Yes?
This might be a bit too detailed, because when I've been working on analysis and modeling, one of the key questions that comes up is how can we distinguish from just a model that kind of shows correlation between two variables, and the kind of causality, is it increasing? Are we increasing prices, that kind of thing? And is that addressed in an AI model, and how is it addressed? And because it is, when you do a model, and especially when you're thinking about predictive models, what you are most interested in is, if we change one of the variables on the independent side of things, is that going to affect the dependent variable, or is it just depicting a correlation relationship? Is that actually which direction of causality? Can you determine that from the AI model, or is there ways of?
Yes. So as I mentioned, depend on the algorithm that you try. For the predictive model, I think feature engineering is a really important part. And sometimes, as I mentioned, creating, because it is so difficult, having the amount of the data, I think, let to go back to the basic, I think. So at the beginning, the amount of the data that you have is important. How much data did you have? And based on that, then you can think about the next processes, specifically in the feature engineering phase. So if you have a loss of data, so maybe we can, for example, remove some of the, for example, irrelevant data or ignore them. Or maybe if you have a small data set, what we can do, we can think about, for example, feature generation or feature creation, creating new feature out of the existing one, or transforming them to the different forms. Or sometimes I think integrating or getting public available data sets to improve our, I think, quality data. All depend on the task at the end of the day, if you want to be honest. So there is no solid principle to follow and say this is the right way to, for example, to improve and consider, for example, just considering the correlation between the features with the target variable, or thinking about just increasing the size of the data, or maybe integrating some irrelevant data. As I mentioned, if you remember at the first slide, when we trained at the end, when we evaluate, we need to check, is these model can meet our business goal or not? This is the question. And based on that, we need to go back. And I think because of that, I mentioned depend of the task, the data type, you can consider different technique. Let's say, for example, if you have a visual data, so you can use the augmentation technique to generate new data. For example, if you have a photo, let's to flip the photo, let's to reverse the photo. So just to generate new data, this is a very simple. Or for text, so there is a different techniques that we can consider based on the task that we have. I don't know.
My second question was related to yours, so thanks for asking it. But just going back to variables and data, wouldn't the choice of algorithm and data model depend on the relationship between variables? Mm-hmm. And when you collect data, you don't know anything about the variables and how they impact each other. So how do you make the choice about what data to use to create initial models, model prototypes to test those relationships, so that you can determine what algorithm to build?
Yeah.
And what relationship.
So, in fact, I think as a personal preferences, always I try to, based on the size of the data, I try to just grab a small amount of data, train some models, and then check the output of the model, and then go back. And sometimes I will try to use the AutoML. So if you're familiar with the concept, so you can, for example, specifically for predictive and with the cloud platform, you can use these option, and the cloud platform try to train multiple models for you and compare them, and somehow offer you the best model at the end. And you can go back and check what kind of data they used, what kind of feature engineering process went through the training, and so on. So again, as I mentioned, it depends. It depends on the task, the requirement of the modeling, and also sometimes the evaluation metrics as well. Yes?
In line with what she's saying, in all, is it in all circumstances you have to get rid of like outliers or like future selection, like pick the one, in order to avoid like biases? Is it not okay sometimes to look at if you can normalize the data and then?
That's true. So definitely, with the outlier, when we try to remove them, it in fact try to avoid the skew in the output. Because, for example, let's say if you have some outlier in our data and we train the model using those outlier, at the end it will shows the impact on the predictions. So removing outlier is, I think, one of the norm. But regarding the bias that you mentioned, again, we have some sort of techniques to check the bias in our data set and also in the prediction of the model. And also for debiasing, we have three types of techniques. Before training, during the training, and after the training. So debiasing before the training is by looking at the characteristic of the data set, checking for inclusiveness of the data set, finding the roots of the bias. For example, sometimes it's so difficult, specifically with the textual data, to remove because it's a part of the culture or maybe part of our daily life, this bias, and is somehow integrated in our daily life that is so difficult to remove. During the modeling, we have some techniques that you can tweak the structure of the model to consider and the bias during the training. And after the training, we can add the layers or some sort of additional processes to fix the output that is contained the bias to generate a better output. If you like, I can share a list of those techniques about the debiasing later on. Great, I think it's better to go ahead and look at some of the AI project management methodology. So I think it's a very similar concept to any other engineering. Cross-industry standard process for data mining is one of the, I think, or CRISP-DM, one of the very common techniques to manage AI. It's a traditional one, I think it's a classic, and from around the 2000, this methodology used for specifically data mining processes and project, and still lots of people try to use that one. It has a different step from the business understanding, data preparation, modeling, evaluation, and deployment, and in the center we have the data. But if you want to look at a little bit modern version of the CRISP-DM methodology, you can think about the data science lifecycle or team data science processes from Microsoft. So this is a methodology introduced by Microsoft. It has 4 phases. Just go back to here and grab the laser pointer. So it has business understanding phase, data acquisition and understanding, modeling, and deployment. But there is some sort of sub-steps in each phase. And there is a comprehensive documentation on the Microsoft website if you want to go through the process, and it will help you to understand more. I will skip the description, but I'm just trying to give you an idea what kind of methodologies exist. SEMA, sample, explore, modify, model, and assess. The same concept, but in a different environment. This is a methodology presented by SAS. SAS is one of the main players, I think, one of the old players in the machine learning area, and they try to follow this methodology. It has lots of similarity with the CRISP-DM, but also there is some differences. Kanban, I think, is one of the famous one at the moment, and it's used in different sectors when you have a different, in fact, you have a board with different columns, and each column represents the process of the progress of the task, and you can assign them. So there is a specific version for data science, or you can follow your intuition and create a new board for yourself. Scrum for data science, this is another, I think, bespoke methodology just for AI and data science. When you try to go through the iterations, and in each iteration you will change the weight between different tasks. For example, as you can see in the first sprint, 10% for creating dashboard, 20% for modeling, and 70% for exploratory data analysis. But in the second sprint, it could be changed, and I think this is just some sample, but you can consider that one as a basic or basis for project management. And data-driven Scrum is another version of Scrum when you try to, I think, combine or integrate Kanban with the Scrum together somehow to create a board. In this case, you have a backlog of multiple tasks. Then you try to assign those tasks in 3 different categories: create, observe, analyze, and then assign those inside the combined board, and again iterate through this process multiple times, finally to get the project done. Do you familiar with any of those methodologies, or are they new somehow? Do you have any experience using any of those, or no, new? Great. So they have a different concept. I think if you want, you can look at the documentation for each of them. I think it will be great. Budgeting as a last concept for subject for today is how we can budget for AI project. It's a very tricky area. Lots of people try to avoid to speak about that, but I select to share some maybe basic consideration. So when we try to create a budget or maybe evaluate the cost of an AI project, you can think of 3 different areas: development cost, operational cost, and hidden cost. So development cost is really clear. Software, people who they want to develop, hardware you need. So this is the development part of the cost that is related to the development of the AI system. Operational cost, when you train the model, and now you want to put this model in a production environment and keep it using this system. So it could be a cloud service, it could be a cost for ongoing maintenance or tracking of the system, or maybe updating the AI system. And the third category is hidden cost. There is some cost that we cannot see from the beginning, specifically with data acquisition. When we want to access the data or processing those data, I think sometimes we try to skip those costs, to consider those costs during the budgeting for the AI. And finally, unexpected technical, specifically with the AI landscape, because lots of changes. Every day we can see some progress, new versions of the libraries, frameworks coming out. You need to be careful. You need to think about how this model can operate in the production environment without impacting any other parts, how we can keep this one running. Or the nature of the data will change after a while, and the model will degrade and the output is not good as before. You need to retrain again. And so this is some sort of consideration that we need to have. So in fact, if you want to think about that, this is just a rough idea, because there is lots of other elements that should be considered. Development cost, hidden cost, operational, just to give you some category that you might be considered during that. And for budget allocation, you can prioritize your budget based on different phases: research phase, development phase, production phase, maintenance phase. So you can allocate budget for each of them. And as I mentioned, try to definitely consider the unseen challenges during the production. And finally, I think one of the best suggestions is to think about the AI system in a long term and budget for a long term. Specifically, I think AI system will generate value in a long term, not in a short term. So considering the maintenance and running costs for those systems is important. And when you try to grow, I think the scalability is another concept that should be considered during the budgeting. How we will scale our AI model systems. And some suggestion for optimization, cost optimization. The first thing is about the resource allocation strategy. So try to keep a balance between in-house and outsourcing process and expertise, and somehow try to invest on in-house. Specifically for lots of organizations, it is better to invest on in-house talents, train them, use them, instead of outsource the problem to the specialists, look like us, to develop, for example, product for them. Then for cost optimization, so using the open source available framework is one of the options. That to say, for example, instead of using Azure or AWS, for example, services for MLOps, there are lots of open source frameworks that you can use, so it can save costs for you. And also considering the cloud computing instead of on-premise is another option. Definitely spending, I think paying for the service for the cloud is much better compared to having on-premise services or servers to keep everything in-house. And finally, return on investment and performance metric. Definitely for any AI project, you need to have some sort of KPIs to evaluate the performance and measure the success of the projects, AI project. And also for return on investment, you need to ensure that is meet the goals set from the beginning. So evaluating those is important. As a visualization, this is I think a Gartner research. They checked the AI global return on investment from 2015 until 2019 to see how the organization satisfied with the first year of deployment of their AI system. So the blue one is far more than expected. The dark, I think, blue is more than expected. The gray is as expected, and the maroon is less than expected. As you can see, the return on investment, I think, for AI project is really high. And I think lots of people and organizations, they achieved what they planned. But you need to consider lots of things during this process. So, let's go back. Is there any questions, consideration, thoughts about this topic, specifically with the budgeting and cost?
In terms of the cost or budgeting consideration, do you have any framework or kind of more systematic approach? Because there are a lot of sectors to cover, but is there any kind of more systematic framework you think you're looking for that?
So the question is there any systematic framework for budgeting and cost planning for AI project? To be honest, no. If I want to be honest, because it's so difficult. And sometimes you could have, specifically if you have, for example, a similar use case for different vertical. So you can define a package that, for example, the output or the product is clear, and you know how much it will cost you for developing, for maintenance, or for running. But generally, if you want to have a framework for budgeting, is so difficult because the requirement is different. Let me to say in another way. Let to consider, for example, a scenario when you have a customer and they want to understand the sentiment of their customer for their, for example, call center. So if you try to, for example, train a model from the scratch to predict the sentiment for you, the budget is really different compared to using a trained model and just, I think, using a cloud, for example, model or any kind of those technology and just put them together as a product for the customer. So based on that, I think there are lots of different, and sometimes specifically, as I mentioned, is not, it's a very dynamic environment, AI. You cannot expect to get the best model with the first round of training. Sometimes you need to go multiple times, and each training process can cost lots of money in some cases. So because of that, it's so difficult to define that. But you need to create the boundaries and scope for the project that you want to go through.
I think generally, just thinking about it when I translate it to my organisation, the approach we took with the budgeting was to move fast and fail fast.
Exactly. Yeah.
Because it's all a bit of a, everything's a bit hazy. We don't exactly know what it's going to do, but we're going to try something and taking more of a pragmatic. We're going to create a concept and we're going to see how it goes, and with each increment of each. And failure's not bad. Failure just shows you tried something, it didn't work, but then what do we need to revisit, what happened, and to reassess that. I think we iterated through that cycle, and just to work out how long it costs to fail sometimes can be a good measure of how many times we need to fail in order to come up with a good response. And that was generally the approach that I took when I was trying to sell it to my hierarchy and get corporate buy-in, really.
Exactly. I think this one of the, I think, is understandable specifically to fail, but quick fail instead of a long run and spending lots of, I think, budget on a project that cannot get the output. And as I mentioned, always when we try to compare AI with the other engineering principles, this is the difference. We are not sure. There is not a, let's say, there is not a predefined process to follow we have for training, but for the specific budgeting and cost, it's so difficult to consider that. For example, still we don't know on the internet, if you search for the training cost for ChatGPT, they said between $4 million to $12 million. So this is not a small range, it's a really big range, and this is just prediction, and they didn't share that. But it needs lots of, I think, consideration. By the way, it depends on the policies in place in the organization and how they want to approach this project. Thank you very much. So as I think takeaway, I want just to recap everything. We discussed about the AI project life cycle, the different steps, which has from the business problem scoping, data collection, data integration, processing, feature engineering, modeling, evaluation, and productionization, and finally monitoring. Common technique for data pipeline. This is just very simple one, ETL, ELT, or API integration. and exploratory data analysis when we try to visualize some sort of features of our data set, having a data strategy when we try to outline the process of data collection, management, security, and all those concepts in one document. And a successful data strategy should be aligned with the business goals. Feature engineering is a part of the process that can prepare the data to feed to the model. We will train the model by passing the data, and finally, there are different methodology to use during this process, from the CRISP-DM, TDSP, SEMA, Kanban, Scrum for data science or data-driven Scrum. So thank you very much. If there is any questions, anything, so we are happy. And if you like, you can follow us on LinkedIn for get more updates. We are going to publish, I think, weekly somehow update about the new technologies, new innovation in the AI area very soon from the 1st of the February. So every week we will try to publish somehow an update, very short update, to give you a highlight about what is going in this area specifically. What has been changed, what has been introduced in the past week, and so it will be a good summary for the people who they want to keep up with the updates. Thank you very much. So we are done. I'm here if you have any question. Otherwise, please help yourself and enjoy the rest of the day. Thank you.